All right, for 4-3 notes, notice I don't think we've ever done this before yet, but sometimes since we share these notes, we don't all do them exactly the same. So you're not actually going to turn to the 4-3 notes that are written out for you and labeled this time. Okay, so you're actually just going to go to the blank page. You'll find a page where I have just typed 4-3 and it looks blank, right? You might have noticed what some of those are for, and that's for any time that we just have a note that we want to make ourselves. So go ahead and go to that blank page. You're going to just go ahead and write out the notes yourself, okay? And label it your notes, and here we go. Okay, so polygons. Remember, polygons, guys, are just any number-sided shape. So it could be triangle, square, rectangle, could be any number of sides. Okay, so polygons are what we call similar, and that's what chapter 4 is really about, is similar polygons. So they are similar if corresponding angles are congruent. Remember, corresponding means in the same place. So if corresponding angles are congruent, congruent means equal, and corresponding sides are proportional. Hence the reason we've been talking about proportions for the first couple of days of algebra in this chapter. Okay, proportional means writing those fractions, right, and having them reduced to the same thing. There's some symbols that you need to know for this section. Okay, so be careful with the symbols. Notice this one here. It just kind of looks like a squiggly or an ñ for Spanish. That squiggly means similar versus this squiggly with an equal sign under it or an equal sign means congruent. Okay, so we are dealing in the chapter with just similar. We'll do congruent in a later chapter. Okay, so really watch those symbols. Be careful for yourself. Okay. All right, next, go ahead and write down these directions for yourself. So use the names of similar triangles. To do the following. So part A, we want to list all pairs of congruent angles. And in part B, we want to write all ratios of corresponding sides. All right, so definitely we're trying to work our way into a shortcut. Okay, but first we need to kind of get down to what all of this stuff means. All right, so notice the symbol triangle. You know angles are labeled with capital letters, so these are all capital letters. If I tell you in problem 1, triangle ABC is similar to triangle DEF. Okay, let's just analyze what that means to us. So what it should mean to us, just like you might be similar to somebody else in this class, right? You're both human, maybe you both have brown hair, maybe you both have green eyes, but you're not the same person, right? So if these triangles are similar, I'm purposely going to make them look a little bit different. I'll give them the same shape, but I'll make one smaller and one bigger. And I will label them like we've always said. I'll always put the A at the top and I'll kind of go counterclockwise. So here's ABC. The next one was DEF. The letter order does matter. So D is at the top, E, and then F for counterclockwise. And for these to be similar, okay, because that's what that statement says, then I'm going back to my first page and what it said about polygons. They're similar if corresponding angles are congruent. All right, corresponding means in the same place. So let's say these two angles in the top are equal to each other. We can do that with a symbol. The ones in the lower left corner are equal to each other. So use a different symbol. And the ones in the lower right are equal to each other. One last different symbol. Likewise, it says, and for them to be similar, corresponding sides have to be proportional. All right, so I'm making up these numbers, okay, but proportional should mean to you this. So let's label sides A, B, and C 2, 3, and 4 where I've got them. And for D, E, and F, let's label 4, 6, and 8 where I have them. Okay. And what I like to do when I have a problem like this is, and this is just my method, okay, so you can do this how you want, but what I always do is I circle the smallest length in both triangles. So the smallest of the 2, 3, and 4 is 2. The smallest in the right triangle is 4. And I'm going to box the biggest length. So the biggest length here is the 4. The biggest length here is the 8. And the medium length I'll just leave alone. Okay, you can do it however you want. But for the sides to be the proportional, what that means to you is, let's write the proportions. Remember, those are fractions. So I'm going to do the ratio of small triangles, the small triangle to the large triangle, right? Just like when we were doing cats to dogs, men to women. What am I comparing? I'm comparing the small triangle to the large triangle. All right, well, comparing them, I'm going to say the smallest side in the small one over the smallest side in the large triangle, right? The 2 and the 4, the ones I circled, has to equal the medium length in the small one, which is the 3, over the medium length in the large triangle, which is 6, has to equal the large length in the small triangle, which is the boxed one, the 4, over the large length in the big triangle, which is the 8. So to me, that's why I'm circling them and boxing them. I'm just putting the circle over the circle, the one that's not marked over the one that's not marked, and the boxed one over the boxed one. And then you actually need to do the work, okay? Reduce these fractions. 2/4 is 1/2, and 3/6 is 1/2, and 4/8 is 1/2. That's what it means for sides to be proportional. Okay, so I just like to create these notes ourselves so that you're understanding how to use those words. So again, we did the corresponding angles were congruent and the corresponding sides are now proportional, which we just showed right there with those all reducing to the same thing. Okay, now what this is also supposed to mean, and I just led you into it, but the short part of this is supposed to be the following. Without having to draw those triangles, you should be able to use the information that was given to you. And here's how you do that. This information says the first angle and the first angle are equal to each other. Okay, and you can see that in the symbol in the picture. So that's telling you angle A is congruent to, right? Okay, we said we would do congruent triangles, but these are congruent angles, congruent to angle D. And likewise, you can just kind of keep following the pattern. And so now the middle letter is going to go with the middle letter, which is going to tell you that angle B is congruent to angle E. And last but not least, the last letter, the C, goes with the last letter of F. And therefore, angle C is congruent to angle F. Okay, so that's the short way of doing part A, which said list all the pairs of the congruent angles, okay, without having to draw the picture. And then the short way, but it's should be convincing you guys by looking at the picture. For B, it says write all ratios of corresponding sides. We're talking about call these sides by their names. So notice in the small triangle, the shortest side, where it's labeled 2, that's also segment or side AB, if you will. Okay, so I'm going to say side AB over side, the small one in the big triangle, is DE. Okay, now I want to start talking to you about how am I going to do it if I'm not looking at a triangle. Here's what I look at. Okay, at the top, I again go back to this part, number 1, and I say side AB, so these first two go over these first two. So AB over DE equals, next I always do, so that's the first and the second letter. Next, I always do the second and the third. It doesn't matter how you do it, but if you always want to match me, I will always be consistent. So now I'm going to go with the second and the third letter, second and third, okay? And I'll say side BC over EF has to equal, erase one more time. So I've done the first and second together, the second and third together. The last thing I haven't done is the first with the third and the first with the third. And you can look in the picture to convince yourself. And so that would have to equal side AC over DF. And notice if you put those numbers in with those letters, you get exactly what we had over here. Okay, if you put all of those lengths in. All right, so now that that's cleaned up, try the second one for yourself. So again, we want to try to have you not have to draw the triangle, right? Because we want this to be fast. So if I just flat out give you the information that triangle ZXY, remember these are capital letters and you should be crossing your Z's. If I tell you triangle ZXY is similar to triangle AMF, I'm confident you could draw the picture, but let's skip it, okay? Let's go with the shortcut. So in A, again, we're supposed to be listing the pairs of congruent angles, okay? That means I'm simply going to say angle Z is congruent to angle A. And why did I know that? Because they were both the first letter up above. Angle X would be congruent to angle M because they're both in the middle. And angle Y is congruent to angle F because they were both at the end. That would be my full answer for A. All right, B, they're asking us to write all the ratios of the corresponding sides. All right, so the first side would be ZX because it's the first two letters. And they would be over the first two letters in the next triangle, AM. Now I'll go to the second and third letters. So side XY over side MF would equal the first and the third. So side ZY over side AF. Okay. Go back and rewatch that if you need to. That should just be simple, straightforward, based on matching them. Okay. Let me know if you need some clarification. All right, so next, that is those last ones where we were telling you're similar, okay? Now you also need to be able to determine yourself if they're similar and do some work. So write new directions for yourself, okay? So determine if the polygons are similar. And then if they are similar, if similar, find the scale factor of A to B. Okay, capital A to capital B. All right, so first of all, we need to very carefully draw these pictures. Okay, so let's give you a four-sided shape. And here I'll just give you a smaller one. Let's call this picture A, this picture B. Be careful to mark these with single marks in those 4 places. And then let's do double marks in these 4 places. Okay, let's put lengths of 2 and 6 in the appropriate parts on A, and lengths of 1 and 3 in the appropriate parts on B. And now you have everything in the picture you need. Okay, so first of all, determining if these two different shapes, right, these two polygons are similar. You've got to go back. You've got to have defined and memorized what a polygon is similar from the very first screen that we did. Okay, so first of all, are corresponding angles congruent? Well, notice, and I don't care if they're even turned, guys, but notice you have two sets. I'll just put a dot next to them while I'm talking to them. But you've got two sets across from each other of double lines, and you've also got two sets across from each other of single lines. Okay, so that takes care of that. Next, are corresponding sides proportional? Okay, well, here I go again. I'm just going to circle the smallest length in each of the pictures. Again, I don't care if this is turned. One could be on the top, one could be on the side. And I'm going to box the biggest length in both of them again. And now I'm going to do the same thing that I did last time. I'm going to say smallest over smallest equals biggest over biggest. Now, when I know I'm doing a scale factor, this is just me, I start with the biggest first, okay? Because this is going to be something that's new to you. So if I do biggest of 6 over 3 equals the smallest of 2 over the smallest of 1, well, is that true? Does 6/3, so it means like really analyze this and do this math, see if these are equal. Does 6/3 reduce to 2 over 1? And 6/3, both those numbers reduced by 3, you do get 2 over 1. So if you fully reduce that fraction, that's what's called a scale factor. Okay, it's kind of like building a model, like a model airplane, right? The model airplane is smaller than the real plane, but it's a scale factor of, and you do have to read the problem. So please notice up here, it said A to B, right? This is like our proportions. A to B is different than B to A. So notice I did the bigger picture, the A, over the B, and the scale factor is 2 to 1. And it just comes straight from that reduced fraction. Okay. You could, don't forget, write that as 2 to 1, which is what you got over here when you were reducing it. But guys, this is what we're going to use. When you're talking about a scale factor, we're going to write it this way. Okay, so we'll say use this notation for answers for scale factor. Now, what is that supposed to mean to you? It's supposed to mean to you that A is twice the size of B, or B is 1/2 the size of A. Okay, that's what that proportion should mean to you. All right, let's go with the same question. Okay, so if I'm asking you, determine if the polygons are similar, and then if they're similar, find the scale factor of A to B. Let's just do another picture. Okay, so same directions though. So for number 4, let's give you these two. Smaller one we'll call A, bigger one we'll call B. All right, let's put right angles in all 4 corners. For both of them, and let's give you length of 4 and 2 for A, 8 and 6 for B. Again, if that's bugging you, remember we never ever trust what the picture looks like in geometry. We trust the information given to us. All right, here we go. Are these polygons similar? So first check mark from the first screen, are corresponding angles congruent? Well, I notice that all 4 angles in both of them are right angles, right? So we've got that part down. And corresponding sides have to be proportional. All right, so here I go again. I'm going to circle my smallest lengths. So I'm circling the 2 and the 6 this time. Remember I said I don't care if they're turned. And I'm going to box the biggest length, 4 and the 8. And I want to know, is the smallest over the smallest, so 2 in the left one over the smallest one in the big one, which is 6, is that equal to the largest of 4 over the largest of 8? Okay, and you need to do the math, so I hope you'd be reducing and telling me 1/3 and 1/2, and I'd hope you'd tell me these are not equal. So the work I'm looking for is for you to tell me that 2/6 does not equal 4/8, and therefore these are not similar. Okay, don't alter your answer. It's not no solution or can't be done or impossible. It's not similar. That's exactly the answer we are looking for. Okay? Okay, so see what you can do with that.